In this video, I'm going to show you how to make a reflectance measurement. As a sample application, I'm going to show you one of the most common applications that's used for reflectance, and that's a color measurement. The components that we're going to use for our reflectance measurement are our Ocean HDX spectrometer. This one is configured for the visible NIR wavelength region, which is ideal for the color measurement we're going to be making. We're also using one of our tungsten halogen light sources, the HL2000. This is perfect for those color measurements with lots of energy in the visible and NIR wavelength region. Of course, the most important part of our setup is going to be our reflection probe. And this is going to enable us to couple our spectrometer and our light source to our sample for our reflectance measurement. The other accessories that we have here are our reflection probe holder. And then we have our reflectance standard, which we're going to use to take the reference for our reflectance measurement. In this case, we're using a Spectralon standard, the WS1. The first step in our setup is going to be to plug in and get our light source ready for our reflectance measurements. So first, we're going to plug in. We've got a shutter, which will enable us to take our dark measurement without turning the light source off. We have a nice warmed up light source, and if we turn it off, then we're going to need to let it warm up for another 20 minutes before we use it. On the front of the light source, we have this screw which will enable you to adjust the light levels. So if you have saturation in your spectrometer, you'll be able to decrease those light levels to avoid saturation. The next thing we're going to hook up is our spectrometer. We'll connect our power cable and then our USB cable. Next, we're going to add our reflection probe. What you'll see is we have one end of the probe that has a common end and has our ferrule. This is the part of the probe that we're going to use for our reflectance measurements. The other end of this assembly has two different fiber legs. We're going to take our light source leg and we're going to connect that to our light source. The spectrometer leg is going to go to our spectrometer. One thing to keep in mind is that these are glass fiber optic cables, so you want to be mindful not to bend them or twist them too much, or you could break the fiber optics inside. We can then use a sampling accessory like our RPH-1 reflection probe holder to enable us to make either specular measurements, where we're looking at reflection at 90 degrees, or diffuse measurements, which we're looking at reflection at 45 degrees. You need to make sure that the distance and the angle between your reflection probe and either your reference or your sample remain absolutely consistent throughout your measurements. Last but not least, we're going to need a reflectance standard for our measurements. In this case, since we'll be doing a color measurement and a diffuse reflectance setup, we're going to be using our diffuse reflectance standard. It's very important when choosing your reflectance standard that you pick a standard that has a level of reflectance that's very similar to the reflectance you're expecting from your sample. We are ready to start making our measurements. So the next step is going to be to start our OceanView software. You're going to go to Spectroscopy Application Wizard to find the Reflectance Wizard, which will help you get your setup into reflectance mode. So we're going to pick the reflectance option. We recommend sticking with the active acquisition, so no changes needed here, and you can just click Next. Next, we're going to set our acquisition parameters. And these are going to be the parameters that are used to determine how much light gets into the spectrometer and even to help improve our signal-to-noise ratio. The first thing that you're going to need to do is adjust your integration time. At 100 milliseconds, which is the default setting in the software, we are completely saturating the spectrometer. How would you know that? We have a flat line that goes across the top of the spectral window, which is indicating that the spectrometer can't see any more light. It's completely saturated. So what we're going to do is adjust our integration time to get that spectrum into the ideal range for our measurements. To do that, we're going to place the probe onto our reflection standard. So we're going to click the automatic button to help us get our integration time. It will set it automatically for us just below that blue line. This is going to give you your best performance. The next two settings that we have in our acquisition control panel is scans to average and boxcar. And these are two settings that we highly recommend because they're going to improve the signal to noise ratio for your measurements. In this case, at such a short integration time, I can do lots of scans to average. I'm going to start with 25, but I've done as many as several hundred, depending on how quickly I need to make the measurements. Next, we're going to set our boxcar smoothing value. And in this case, whatever value we set in the software is going to average pixels on either side of each pixel. So for example, if I pick a boxcar setting of 5, which is what I'm going to use for these measurements, that's going to average 5 pixels on either side. The result is that we get some degradation potentially in our resolution, but it's going to give us a big improvement in our signal-to-noise ratio. The next step that the wizard will ask you to do is to store dark spectrum. We're going to close the shutter on our light source, so no light is getting into the spectrometer. Once you've collected your dark spectrum, the next step is to turn on linearity correction. We're just going to place a check in that checkbox, and that's going to give us the most linear data that we can get out of the spectrometer. We click Next to collect our reference and our dark spectra. We're already all set up for the reference spectra here. We just need to make sure to open the shutter on our light source so that we're illuminating the reflectance standard. We're going to click the light bulb to store our reference spectrum. Once that's been stored, we're going to click Next. We're going to close our shutter again so we can take a dark measurement. We're going to click the light bulb and we're going to finish the wizard. We're going to open our shutter again, so we're illuminating our reflectance standard. And for a standard reflectance measurement, we're ready to go. You've done everything you need to do. Now you're just going to place the probe onto your sample and collect your reflectance spectrum. For color measurements, we're going to run through our color wizard now to specify the specific color parameters and other details for that measurement. We're going to open up the wizards by clicking here, and this time we're going to pick the color option. Since we've already got an outstanding reflection measurement going, we're going to go ahead and use existing processing. We have the option, as you can see here, of choosing from several different quantitative color values that we can output in the software, as well as picking our observer and illuminant. Then we're going to click Finish. Using this, we can actually see in CIE color space where our colors are falling. And what you'll see in the software is changes in the chromaticity diagram as we look at different colors. To make the measurement, all that we're going to do is place our probe holder directly on the sample that we want to measure. And as you see in the software, we can see changes in the color values and also in the chromaticity diagram. As we change to a different color, again, we can see how the chromaticity diagram is reflecting the color that we're actually measuring. Whether you're looking at color consistency, matching paint colors, we're actually getting quantitative values that will enable us to ensure great consistency. So what we've gone over today are the critical steps required to set up your diffuse reflection measurement. So we covered setting up the software. Don't forget to warm up your light source for 15 to 20 minutes. We've talked about measuring your reference, measuring your dark, getting into reflectance mode. And in this case, we took it a step further and actually went into a color processing mode to get quantitative color. For more information on ocean products, reflectance, or anything else, please reach out to us or visit us at Ocean Insight online.